Welcome to Excel Tips and tip number 47. And in this week's tip, we're going to be looking at some indexing. Quite a common and important part of modelling, and something which can be often done incorrectly. So we're going to show you a quick couple of ways to do it. So at the top of the sheet at the moment, we have got our data, essentially saying the years that we want to grow, the growth rate of 4%, the base index being 100, and the number of quarters being 4, which is your N. First, we're going to have a look at the annual index. So it's simply just saying what the amount is. So Q6, which is your index base, times 1 plus the growth rate, and simply carry that one forward, and that will work just fine, except for you change it to what the prior period was from period 2 onwards. And from this, we can actually check that it's growing correctly. So what's the cumulative growth, and what's the year-on-year growth, and you can see that it's compounding out nicely. Now we go to something probably a little bit more difficult, and this is where mistakes tend to get made because it hasn't been decompounded correctly, but something like quarterly growth. Now, if you use the interest over number of periods method again, like we have above, you'll see very quickly it's exactly the same formula, but it escalates a lot quicker because it's compounding on the prior period, and obviously because it's quarters, there's 4 times the periods in the year. So we end up with a result which is going to be higher than what it should be. If I can find the corresponding, so year 2 should be end of year 1 should be 1.4. That's what I was looking for, and you can see it's 1.406. Year 2, 0.16, and it's 0.29, and so on and so forth as you go forward. And while it seems like a minimal amount, if we're talking millions of dollars here, it can be quite significant very, very quickly. A way to correct this is actually having a flag, a quarterly flag, and that's when the escalation happens, or a flag on the year end. So you can say this is quarter 1, quarter 2, quarter 3, and then the flag kicks in from quarter 4. So you'll say if that equals 1, the cell in front equals 1, then apply your escalation to the prior period, apply your index base, 1 plus the inflation to the power of the number of years, and as you go forward, the year counter will go up. Otherwise, prior period, and you can see that automatically links straight back as we're going forward. The only problem is it doesn't work if it needs to be indexed on a quarterly basis, and as a result we need to do a decompounded rate, and the decompounded rate is this formula here, 1 plus I to the power of 1 divided by n minus 1. And what that does is it actually allows us to see what the rate should be per quarter, but still give us the correct quarterly amount. So in this formula you'll see Q6, 1 plus and 37, which is our decompounded rate. If I go to the decompounded rate, you'll see it is the 1 plus Q5 to the power of 1 plus Q7, which is the number of quarters, minus 1. So you can see that's the decompounded rate. Now, as we go forward, you'll see it just stays on that decompounded rate. Now going on prior period, plus 1 plus the decompounded rate, and you'll see 1.04, 0.16, and 0.49, which is correct, but you've also got what the decompounded or the inflated amounts should be per each of the quarters. This formula here is very, very useful. So if you ever need a decompounded rate, that is something which is pure gold. I can't stress it enough. I've used that formula thousands of times. That's it for indexation. I hope that helped some of you guys, and we'll see you at tip number 48.